All right, in your last video, you learned what transformations are. And then specifically, you learned what a translation was. That's the one that Miss Hanson taught you. Um, and so what we're going to do in this video is talk about a different type of transformation, and that's called a reflection. A translation, if you remember from last video, moved a shape. Specifically, we're looking at parabolas. And in this one, we are going to look at a reflection, which also moves the shape, but sort of in a different way and kind of does something different with it. So before we look at parabolas, let's get this definition copied down. So a reflection is a transformation that flips a figure or a graph over a line, creating a mirror image. And probably one of the better examples that I can give you for this before we get to a parabola are your two hands. So if you hold your two hands out in front of you and look at the backs of your hands, you see two mirror images of each other, right? There's this invisible line going between them, and then your hands are mirror images of each other. And if you take your one hand and you fold it over this imaginary line, it matches up exactly with your other hand. And that's what's created when you reflect something, is you take this image and you flip it across this line, this imaginary line, and you get the results, which is a mirror image. So what this looks like with a parabola is here's our parent function here, and we've talked about what the parent function is. And then if I reflect this over the x-axis, it ends up down here. Exact same size and shape, except that it's mirrored across the x-axis right here. Okay. You can also reflect over the y-axis, and that's what we see here. Now this one isn't the parent function because it's actually been translated. It looks like 6 units to the right. So this one is slightly different because it's already been translated, but then it has been reflected across the y-axis here, and there's a mirror image on the left side of the y-axis. What this shows in terms of coordinates is, let's pick a point, let's pick the point 2, 4 right here. If I take that point 2, 4 and just reflect it across the x-axis, it's going to be the same distance away from the x-axis, and it's going to be in the same x position, same horizontal position, and that point ends up here at 2, -4. Okay, so if we compare the coordinates here, 2, 4 and 2, -4, you'll notice that only one thing has changed, and that's the y coordinate. The x stayed the same and the y changed. We can look at another example, say here at -1, 1. That reflects right here to -1, -1. Okay, the x stayed the same, the y became its opposite. And so what that looks like in general is, if I reflect across the x-axis, the point x, y, here's your rule, becomes x, opposite of y. So if x stays exactly the same. If y was positive, it's now negative. If y was negative, it's now positive. Okay. It's very similar here on the y-axis reflection. So let's take our vertex, whoops, I said 6, 0. And when I reflect it, here's the vertex again. That's negative 6 comma 0. Okay, I can look at another example here. 8, 4 reflected all the way over to here and went from 8, 4 to negative 8, 4. And so what you see with a y-axis reflection is that xy becomes negative x, y. Okay. Now, in terms of the equation of the parabola, here our parent function was y equals x squared. And if I reflect over the x-axis, what this does is now instead of opening up, this opens down. And so my equation needs to somehow reflect that. And so how you'll do this is, let's think about what's happening to these coordinates, right? So the point 2 comma 4 became 2 negative 4. So if I plugged in a 2 before, it was 2 squared is 4. But what I want now is I want the point 2 negative 4. So I'm going to plug in a 2 for x, but I want this to be negative 4. So all I really have to do is, this is 4, this is negative 4. If I want them to be equal, all I have to do is toss a negative on the front. And so that's all you're going to do for the equation, is put a negative right there in front of x. So there's the parent function. If I reflect it over the x-axis, this is now y equals negative x squared. Okay. If I reflect over the y-axis, then we said our rule was that I am changing the x-coordinate and leaving the y the same. So if we look at the point here that we had, our equation over here was y equals x minus 6 squared. And if I'm taking this and reflecting it over here, none of my y's are changing, but my x's are becoming the opposite. So what this is going to be over here is y equals negative x minus 6 squared. Okay, so these two things look very similar, but the difference is that here, if you're reflecting over the y-axis, this negative goes directly on the x inside of the parentheses. And if I am reflecting over the x-axis, it's going outside. You can think of this as kind of blocked off by parentheses, and it's going on the outside. Okay.